Site PP56 is one of many caves and rock shelters located at Pinnacle Point, near Mossel Bay, South Africa. The site has been studied by the SAC-P4 project since 2006. Excavations here have followed the natural sediment stack that built up in front of the site after the last interglacial high sea stand, which was around 125,000 years ago. At over 30 meters long and 14 meters high, this stratigraphic record is one of the longest and tallest prehistoric archaeological sequences in Africa. A naturally eroded cliff forms the base of this long sequence. Our excavations into this cliff, which we call the South 848 Wall, have revealed a detailed record of hunter-gatherer occupation at the site from 90,000 years ago to around 70,000 years ago. What makes this record especially important is that a high sedimentation rate has helped to preserve very fine details, like the structure of individual fire hearths from cooking fires, that would be otherwise destroyed in open-air contexts. In 2013, we designed a custom camera platform that would allow us to photograph the South 848 Wall for the first time. This platform would allow us to capture vertical transects of images while keeping important variables like the camera focal distance and image overlap constant. The platform was built around a single aluminum mast that was constructed out of 5 separate pieces, so we could use it to photograph sections from as little as 1 meter to over 5 meters high. Cables at the top of the mast were affixed to bolts in our cave walls, and turnkeys allowed each cable to be tightened independently to secure and straighten the mast. The camera and our 2 flashes were mounted to a movable boom that could be positioned in 5 centimeter vertical increments. We collected our photographs at night over 4 days so that we could minimize the influences of ambient light sources that would affect our color calibrations. After we calibrated the image focus, we then turned off all of the lights so that each scene was lit only by our 2 flashes. In the laboratory, we systematically processed each raw photograph before mosaicing all of the images, georectifying the profiles, and finally bringing the photomosaics into the 3D GIS database. We have maintained the highest pixel resolution of our images within the 3D GIS. Our measurements indicate that details as small as 1 millimeter are visible within the photomosaics, and this is apparent by the individual grains and other fine details that can be seen in the profiles. Stratigraphic features within the profiles even line up with other profiles on different orientations. We can even line up the features with profiles that we collected in previous years. Most importantly though, the visible stratigraphy in our photomosaics accords with the spatial distribution of our plotted finds, which had to be excavated and removed first. Now we can link the stratigraphy and the plotted finds, which include stone artifacts, bone, shell, and other materials, to show that there were periods of increased anthropogenic activity and periods when people came to the site less often. These observations give our team members key information to understanding when, where, and how the site was used in the past. For example, here is the 3D outline of one of our micromorphological samples, number 110601, as it was originally affixed to the section. This is a georectified image of the same sample, after it was removed from the section, resonated, and then cut in half. Stratified ash, charcoal, and shell-rich sediments are clearly seen in these deposits, taken from a combustion feature. And these layers link up with the excavated context of our plotted finds. We can also integrate the individual thin section slides from the resonated slab, which allows us to see the microscopic changes of the sample within its wider 3D context. In this way, we can link micro, meso, and macroscopic scales of analysis to the stratigraphy and spatial distribution of the plotted finds. We can also integrate other sample types, like magnetic susceptibility, which has been shown to be an excellent proxy for identifying burnt remains. For example, this is a section of the South 848 Wall stratigraphy that we call the Copus shell. It is a 15 centimeter thick, shell-rich lens with over 950 plotted finds that is separated into 2 lenses. In between these lenses is a layer with 80% fewer plotted finds within a charcoal-rich matrix. Magnetic susceptibility samples taken from these charcoal-rich sediments have higher values than in the surrounding sediments, which indicates that these charcoal-rich sediments were heated and that they were part of an in-situ combustion feature. In this case, it does not appear that this particular fire hearth was used primarily to dispose stone tool debris or other waste. We have found many other new and useful ways to use these photomosaics to study Site PP56. But what is clear already is that these images demonstrate that it is possible to model and carefully observe the relationships between stratigraphic profiles, excavated archaeological materials, and geomorphological samples within three-dimensional space, regardless of when the different materials were excavated or what is still preserved at a site.